Hey guys, we're going to look at acceleration today as an application of the second derivative. So just like we did yesterday, we're going to start by thinking of just a simple linear graph. And we're going to think about this instead of displacement or distance. I want you to imagine that we're graphing velocity as a function of time. And imagine that we have just like a linear graph. And we're thinking about what is the slope here. And so we're thinking the change in velocity and the change in time. So our slope will be change in velocity over change in time. What would we have thought of that in a Science 10 situation, or even in a Physics 20 situation? That slope, we would have thought of that as acceleration. So when we're graphing velocity versus time in science, we simply think of the slope of that graph equal to acceleration. I'm just going to abbreviate acceleration there so it fits. And so the same jump that we made yesterday, going from displacement to velocity, we're going to make today with acceleration. So we're going from velocity, or speed, and we're going to take the derivative of that, and that will be acceleration. Or if you want to think of that as the second derivative of displacement, you can. So there's a couple different ways to write that. I like to just use A equals V prime, which is the same as S double prime. Now, whatever notation you encounter, we need to be comfortable with, so I've got a couple different notations here. And so just like we did yesterday, we want to use just some simple scenarios to start out with. And we're going to start by finding the velocity. So here's the displacement. And we're going to take the derivative of this to find velocity. So velocity as a function of time, in other words, S prime as a function of time, will be 3t squared minus 6t plus 2. Okay, and then the acceleration, as discussed above, is the first derivative of velocity, or we could think of that as the second derivative of displacement, and that's 6t, minus 12. Okay, so there's the two statements. There's the velocity, and there's the acceleration. So after 1 second, that's v at 1. So 3 times 1 squared minus 12 times 1 plus 2. And we've got that as 3 minus 12 plus 2, negative 7. And that's meters per second, I guess. And it hasn't been defined anywhere here, but we're going to, meters and seconds. There we go. Okay, and now the acceleration at 1 second, I'm using the other function, 6 times 1 squared minus 12. The acceleration is going to be negative 6. And we'd say this is meters per second squared. Okay, and so now we've answered this part. And now the next question is, it's speeding up or slowing down. Now, most of you are going to look at that and say, negative acceleration, it is slowing down. Well, this is a bit of a mistake in your thinking, because in order for something to be slowing down, the acceleration and the velocity have to be moving in opposite directions. Okay? Now, this is the slowing scenario. And you can think of that on Earth. If you think about throwing an object up in the air, the velocity is up. Well, the acceleration is down, and so the thing is going to slow down. But as soon as it's falling and the acceleration is down, it's going to speed up. So to speed up, we need to have them in the same direction. And this is the speeding up scenario. And so this is the case where, because both of these are negative, then together it's speeding up. Okay, yes, it's moving in the negative direction, but the acceleration is also in that direction, and so it's going to be accelerating in the negative direction and thus speeding up. Okay, so this is a big thing. You want to nail that down for yourself and just get used to that. Determine the velocity and acceleration of this particle after 5 seconds. So we're going to go through the same thing. Let me adjust my camera here. So the velocity after 5 seconds, 3 times 5 squared minus 12 times 5 plus 2. So 25 times 3, 75 minus 60 plus 2, 17 meters per second. And then we want to think about the acceleration after 5 seconds. And we've got 6 times 5 squared. Sorry, not squared. Did I do that before? Oh yeah, not squared. Haha, I got away with that one because it was 1 squared, but that was a bit of a mistake if you look up there. Okay, and then minus 12. So 30 minus 12, 18 meters per second. And this thing is speeding up. Now notice that might feel counterintuitive because the last one was speeding up and it was negative, now it's positive, but the fact that these are both in the same direction means that we're speeding up. Okay, so I want you to give that a try. And I want you to determine the velocity and acceleration at 3 seconds. And then after that's all done, consider whether it's speeding up or slowing down.